Awesome. All right. Hi, everyone. Welcome to our beginners session on graph databases for Python developers. As many of you know, if not all of you know, the creator of the Python language, the esteemed Guido van Rossum, created the Python language and named it after the BBC comedy group Monty Python. Now, this group went on to create the iconic movie Monty Python and the Holy Grail, which follows the comedic adventures of King Arthur and his merry band of knights as they attempt to find and retrieve the Holy Grail. Now, early on in the movie, there is a scene where a famous historian is tragically cut down by a mysterious knight. And at first, this seems to be kind of a throwaway scene, but as the movie progresses, they keep coming back to the scene of the murder, and additional police and investigators start showing up, and they start trying to figure out who had killed this historian. And this culminates toward the end of the movie, where right before the climactic battle between King Arthur and his knights and the French garrison at a castle which presumably has the Holy Grail, right before this fight begins, or just as it's beginning, a convoy of police cars shows up, police come piling out, and they arrest all of King Arthur's knights and himself. So this has never been explained as to how the police decided that it was King Arthur or one of his men that had committed this atrocity. But I like to imagine that on the cutting room floor somewhere, there is an entire CSI episode's worth of crime drama where the police and investigators are diligently going through the crime scene, investigating people in the scenes right after King Arthur had gone through, and stitching together what had happened to this historian. And I like to imagine, as in most CSI episodes, them using a crime map or an evidence board. And this Hollywood trope is fantastic, right? Because it takes disparate pieces of data, a photograph, a piece of document, and connects them with all these red lines. And these lines aren't even like notated. It's just the audience just knows what these lines mean because the movie prior to seeing these crime boards already gave you the context from which you're looking at this board. So you can gauge whether like, oh, this person knows this person or this person is related, right? And the other reason I really love evidence boards is because these lines connect all these disparate pieces of data, it becomes a network, right? And a network is just, another word for a graph. And we're here talking about graph databases. Okay, so evidence boards, how is that important to a Python developer? Well, according to Gartner, the vast majority of upcoming data and analytics innovations will come from graph technologies like graph databases in just the next few years, right? And so the people most interested in these technologies is going to be your data engineering teams, and probably you as a Python developer as well, even if you aren't specifically touching the same things that these roles are. Or maybe you are one of these people, right? You're a data analyst who's going through information in a BI tool, the data engineer who's creating a pipeline for all this information, or the data mad scientist who's looking at all this disparate data and trying to glean new insights for moving the business forward. Okay. And supporting this prediction by Gartner is this great graph-friendly chart from DB Engines, which shows the increasing popularity of graph databases compared to other databases. Now, just as a point of clarity, this chart is showing the increase of popularity of a given technology against itself over time, right? So as time progresses, graph databases become even more popular than it was previously. And so this is not a comparison of today, like, who's using what technologies. Obviously, our DBMSs are at the top of that pile. Okay, so now that we have kind of an idea of why graph technologies, graph databases are important, what exactly is a graph database? Like, how does it work? Okay, so in summary, graph databases are one of four broad NoSQL database categories, right? We have documents, key values, column family, and here I've got a short list of the famous companies and technologies that represent these other NoSQL database technologies. Okay, so graph databases internally are differentiated from these other databases in how it stores data. Right, so you've got a node, which is an object, and it's related to another object, right? So think of a node as maybe like a row of data in a table. And that relationship is stored as a first-class citizen inside a graph database. So this sort of relationship is typically a join in like an SQL a query, but in a graph database, it's already part of the data store. So you can traverse through information very, very quickly. And on top of that, both the node and the relationship can have properties associated with them, right? And so when you can have a node that has a name, a title, a date, you can have a relationship that has some sort of weight or other information if you want to add that as well. And when you do that, this becomes a property graph, right? So this is a type of graph database. Okay, now general pros of graph databases. Again, you don't have to do the typical SQL joins, and schemas are optional. Of course, having indexes or constraints will dramatically improve your query performance, but they're not hard set requirements. So when you're initially setting up, or if you need to iterate, it's much quicker to iterate on a graph database because you can reassign nodes, you can shuffle things around without having to kind of peel apart all the guardrails before putting it all back together, right? And again, since the relationships are first-class data citizens, and you can traverse the data fairly quickly when you attach a graph database to a visualization tool, you can do some amazing discoveries just by perusing your data, right? So for example, say we've got the movie The Matrix. We want to do a really complicated Kevin Bacon game. So let's find the relationships between all the main actors in Monty Python and the Holy Grail and all the main actors in The Matrix. Are there any movies where they're working together? Like what is the tree of relationship between those two clusters of actors? And when you run it, and this is accurate as at least up to 2016, we can see here that none of the main actors from Monty Python or the main actors from The Matrix ever worked directly together in a movie. But there is this long, thin line of actors that are intermediaries that know or have worked with both sets of actors. Right? One of the most interesting ones is at the very top, which you probably can't see, but it's Sean Connery, who had worked with Terry Gilliam on Time Bandits and also with Lawrence Fishburne in Just Cause. And there's another interesting one with Gary Oldman there. But anyways, you can see all these paths visually just by looking at the result from a graph database. Okay, some downsides, or kind of one major downside, is if you are just doing pure transactional data, right? You're just logging tons and tons of data, and you have no intention of analyzing or acting upon that data in the future. Graph databases aren't going to be of benefit, right? There's no reason to use a graph database where another database solution is probably going to be much better for this scenario. Okay. Another way to look at when you might want to use a graph database is this. I love this chart from Manning Publishing. I think it's Intro to Data Science. Okay, so on the y-axis, we've got the amount of data that you're dealing with, right? From small to a very large amount of data. And then the complexity, how interconnected is the data that you're working with, right? From very simple on the left to more complicated on the right. So you can see on this chart, if, like, hey, I've got some project and I'm just storing mad amounts of data, more than my current SQL option can handle, go look at a key value store, maybe a column family. But if you're dealing with lots of interconnected data, say lots of different systems, then you should consider a graph database for your solution. Okay, use cases. I'm not going to spend too much time here because every session here at Nodes is basically a use case. But I will highlight one, which is the Panama Papers. And the Panama Papers, I love this story. So it came out about half a decade ago. This is what initially introduced me to Neo4j, well before I started working here. And what the Panama Papers was, in general, if you haven't heard about it, was the ICIJ, the International Consortium of International Investigative Journalists, got this huge data dump from someone at a bank or a law firm. And in this information was this giant global financial conspiracy. And it was just too much for the ICIJ to kind of figure out. So they built a system on top of Neo4j that allowed a bunch of investigative journalists around the globe to work together and piece together the evidence to figure out who was who. And when they revealed the story, lots of people were fired or prosecuted. And I think 2 congressional acts came from this to help bolster the financial system against this type of fraud that they had detected. Okay, I'll skip past this. Okay, major players in the graph database space. So according to DB Engines, again, the top 10 graph databases are, as you can see here, and you can see Neo4j and Microsoft's Cosmos DB rank really high according to their scoring mechanism. Now, I don't know what their magic algorithm is, but they supposedly take information coming from Google Search, LinkedIn, Bing, a few job search engines, put this all together into their magic cauldron, mix it around, and they get this wonderful ranking system that Neo4j does really well at. So if you're in Greenfield, you don't know which graph database to start with, I would start with this list and move from there. Okay, now those 10 databases can be roughly broken up into 3 general categories. On the far right, we talked about property graphs already. Now in the middle, semantic graphs, these are a little bit different than property graphs. So unlike property graphs, you can't store attributes to a given node or relationship like directly. Like they're all triples, right? They're all using this subject, predicate, object for subject, predicate, value system, right? So if you have an object that represents a movie, one of the connections would be, predicate would be like the name of this movie is string value, right? So you can connect nodes with values or other objects, right? So one would be relationships and one would be like basically a property of a given node. Okay, that's a semantic graph. The last broad category are multi-model databases. Now, these databases basically allow you to have a wide variety of incoming data sources, right? So you could have JSON files, CSVs, you could have other graph databases as a data store. And the idea, and in an ideal multi-model graph database, is you'd have one query language that would be used to traverse all the knowledge in all the different mediums. Now, a multi-model database is very top-heavy, so they can be complicated to implement, but that is an option available. Okay, so now these 3 broad categories, if we chop up those top 10 databases, they fall into these categories. The categories I would not say are like super sharp. You know, some databases kind of drift into other categories and they have functions that allow them to do things that other databases do. But roughly speaking, you can see that they spread kind of evenly across these three categories. Okay, now even with just these 10 databases, as you can imagine, with each one of them, not all, but most of them having their own query language, we unfortunately get a giant zoo of different query languages that you could use to query a graph database. Now, fortunately, there is a working group from some of those graph database companies, including ours, and a few academics who have gotten together into a working group, and they are trying to create an ISO GQL standard, a graph query language standard. And fortunately, they already began a couple of years back. They're about halfway through, and hopefully in the next 2 years, maybe 1.5, they will have a standard out for the market, for the community, for all of humanity to use one sort of standard for querying graph databases. Okay, now GQL, graph query language, should not be confused with GraphQL, which is a REST alternative developed by Facebook, a few guys at Facebook a number of years ago. It's a great protocol, but it is not for querying graph databases. Sort of. I mean, you could use them to query some data from graph database. So like dgraph, which is a graph database, their entire query language is just using a variation of GraphQL. But GQL and GraphQL are distinctly different. Okay, if you're interested in learning more about GraphQL, there was a session I think running concurrently with this one that Will was doing. But there's another talk later, much later. So if you're in the West Coast like me, there's a talk by Thomas who will be talking about Neo4j GraphQL library features. So he'll be talking at 1 GMT, but 5 a.m. Pacific. So if you wake up very early or do not sleep at all, then you could check that one out, or just watch the recording. That also works if you are not waking up that early. Okay. All right. So GQL. Back to GQL. These are the 10 query languages that they are considering as source material for deciding what the future GQL will look like. I am not proficient in all these languages, nor do we have time to kind of go through all of them, but do know that there are differences between each language. Each has their own strengths and weaknesses. But since we're at Nodes and Neo4j had helped develop OpenCipher, I'm just going to talk about Cipher. Cipher is a declarative language, and it is very ASCII art-like, which I'll show you in just a minute. And it's open source. So it was open sourced, I think, shortly after it was originally created. 2015, I think, is the official open source date. Okay, so to show you what the ASCII art looks like here up on top is an example query, right? So instead of select, which you would have in SQL, we've got match. And here we've got things. We got variables and nouns in parens and brackets. Anything in a paren is a node. So the first part of this pattern, we've got person, and we want to, we're doing a dash to a bracket, a relationship with the type called acted in, to an arrow to another node, movie. So this is just a general pattern, right? We want to find people who acted in a movie. And then we've got a filter using the where keyword. So we're just looking for movies that have the title The Matrix, and return me all the names of these people as a list. So if this query was sent to me and I am a Neo4j instance, I will spit back out this list of names, right? Lawrence Fishburne, Keanu Reeves, Carrie Ann Moss, Hugo Weaving. Okay, simple use case. Now, a more advanced use case, but still similar. This is only one of several ways you could do this, but this is a query for getting that graph database or graph subgraph that I showed you earlier between showing actors from The Matrix and actors from Monty Python and the Holy Grail. So here we're just doing several match statements, right? So we're finding two sets of people acting in a movie, because we're going to check for a different movie, and then find the shortest path between that clump of actors with the other clump of actors. And filter, I'm just putting in two titles. Monty Python, it should say Monty Python and the Holy Grail, but it made this very long, so I just shortened it to Monty Python. So anyways, you run this and you return the two nodes for the two movies, so you can kind of see it all connect, and then the path, right? And so a Neo4j instance will put this out, and you've got a graph where you could peruse to your heart's content on what the actual connections between the main actors are and actresses. Okay, so there's an example of Cipher. If you want to play with Cipher yourself, Neo4j has a great sandbox environment with many preloaded data sets that you could peruse through. One of them is the movies recommendation, which I was showcasing. But we've got things like Stack Overflow, Twitch is in there. There's a couple of fraud detection information. And there's also, if you watch some of the YouTube videos from Alex and Michael, they've gone through tons of data and put it into repos that you could just kind of load in yourself and play with. Okay, so this is an option if you want to play around with Cipher. Another option is if you like to learn through kind of more of a narrative style, I suggest looking at GraphVille. This was a new education site that was created by Vlad, who also will be giving a talk later. So tomorrow from here, so 8:50 a.m. Pacific, 4:50 GMT, also on the beginner track, and he will talk about have a lightning talk talking about how he created GraphVille. Okay, Python tools. All right. Here's the good stuff. Okay, so I'm just going to quickly kind of go through the different toolings that we have available for Python, or not just us, but community and other third-party services also have built a number of tools and services to allow you to kind of build on top of all the graph database goodness that has been built. Okay, so the first thing I'm going to talk about are the drivers, which is built and maintained by Neo4j. First one is the core driver. And this driver you can throw into any other Python framework, right? You can throw it into Fast API, Flask, you can put it into a Streamlit app, which I really enjoy doing. And the big thing to remember with the driver is the current version is it uses transactions and sessions, right? So sessions manage, a given query connection, and it will retry automatically for you if the transaction fails. And transactions are basically static functions that have the query kind of baked in, and you're just passing in arguments if you want. And this is the block that gets retried if the session fails for some reason. Okay, if you're interested in seeing this work with Streamlit, David is giving a presentation tomorrow at 8:10 in the morning Pacific on the intermediate track, Rapid App Prototyping using Streamlit and Neo4j. The next driver I'm going to talk about is the GDS client library. So if you've got the GDS package running on a Neo4j instance, you can run the GDS library. And if you're building a Python app and you want to connect with some of those features, the GDS client is a good option to go with. And you can see here, gds.run Cypher. So this client is built on top of the Python driver. So it will run Cypher, with this command. You can just pass in a Cypher string and run it just like you would the driver. So this generally has kind of a cleaner look. But if you use the GDS client to run Cypher commands, the results you get back will come back as a Panda data frame. So just be aware of that. If you're not intending to use the result as a data frame, like you want an actual object, then this may not be the route you should go. Okay. And fortunately, this is a great thing about having a talk earlier on is there's all these wonderful talks happening after me that can extrapolate on the stuff that I touch about. So on the advanced track, Matt is talking about the fundamentals of the graph data science library system and pipelines. And so he's going through a whole bunch of stuff. So if you're interested in GDS, definitely suggest you check out his talk at almost 1 a.m. Next morning. So a couple hours from now, well, 6, 7, 8. Okay, moving on. Okay, so if you don't want to write Cypher in a string and then throw that into a driver, you can use a query builder. And there are a couple of query builders out here. The two I'm going to talk about is Pyfer, which has been around for quite a while and is quite mature. As you can see here, you can basically, you're making Cypher commands as functions instead of writing a Cypher string and then putting that in. Okay. The great thing about their package is they have a kind of an app that goes with their repo that allows you to put in a Pyfer function call and see what the actual Cypher is. I don't know if it'll, oops, destroying my own classes. I don't know if it will go in reverse. So I don't know if you put in Cypher command and it'll give you what the Pyfer call will. So be aware of that. Something worth trying out. And the next query builder is Simple by some folks at Accenture. And it is, again, it's a query builder. So you can see here that it's very similar in terms of making function calls in place of making Cypher string calls. And what I like about Simple is they made it so that when you run it in Visual Studio Code, maybe IntelliJ as well, you get auto-completion, right? Auto-completion, love it. Who doesn't love auto-completion? And also, the creator, or one of the creators of Simple, Roe, is giving a lightning talk on that tomorrow at 5:40 a.m. on the beginner's track as well. Okay. Yes, I was just thinking, how are you? This is all in the schedule, so I'm just kind of highlighting that these talks are coming down the pipe. You don't have to. Probably difficult to write all this down very quickly. Okay. All right. Second to the last thing I want to talk about are OGMs, object graph mappers. So if you don't want to learn or use Cypher at all, you could use an OGM instead and just use it to create and retrieve nodes and relationships. These can be very powerful. GQ Alchemy, created by memgraph, works with both mgraph and Neo4j databases. And they also have a query builder built in, so you can kind of use it for both if you wanted to. Okay, the other OGM is NeoModel, built by our community. And the great thing about NeoModel is there is already a Django plugin that's available. So if you're a Django developer, you can just slap that in and you got an OGM ready to go. So here you can see you just got a sample of how you would define the nodes and relationship classes. And then right here, just one quick example of how you would retrieve nodes, right? Person.nodes all or person.nodes get, and then give it some parameter to find the specific nodes you're looking for. And we don't have anyone, I don't believe we have anyone giving a talk on NeoModel or GQ Alchemy directly, but later tonight, Estella is going to talk about a personal project that she's done so she's built her own OGM. So if you're interested in OGMs, that talk may be super insightful for you. Okay, so last bit of tooling I wanted to talk about is two things. So visualization tools, right? So if you're using Jupyter notebooks, as many Python developers in data science at least use, you can visualize graph database results in a Jupyter notebook. And one example is from YWorks. They have a thing called Y files. So you can put this into your Jupyter notebook, and you can visually interface with your data. And fortunately, at I think midnight tonight, Pacific Standard Time, anyways, Sebastian, who works at YWorks, will be presenting on exploring your graphs with Jupyter notebooks. So that's perfect segue there. And the last visualization tool I want to talk about is NeoDash, which was built by a few folks here at Neo4j. And this is a great tool. So when you spin this up, you get basically this blank canvas with the ability to add all these widgets. And when you add these widgets, they're pretty much they're pre-built for you, except you can tweak the underlying Cypher command that's used to retrieve the data. So you can change the data, you can change the calls to match your specific domain. And there is just a huge host of widgets for you to choose from, right? As you can see from here, you got a number of different charts. You got a map that you can put pins down. You've got a graph visualizer. Yeah, just like this one's a great way to get some information into a dashboard up and running very quickly. And for NeoDash, we don't have just one. We got like 2 upcoming talks that are talking about it. The first one coming up is by Deckel, excuse me, who will be talking about its use in Bloodhound for a community-driven security thing. I should have researched Bluehound more, but he's doing this talk, so check that out. And then also Neil, who is one of the creators of NeoDash, will be giving a talk tomorrow morning on visualizing geographs with NeoDash. Okay, I think that's the end of my scan of Python tools that may be of interest for a new Python developer. And here's my entire presentation as an evidence board. Because I love evidence boards, I don't know why, but again, it just succinctly kind of visualizes everything, although we don't really have a victim per se here. But anyways, if you have questions or want to reach out to me, I'm available on LinkedIn, which is where I'm usually at most of the time. I do have a Twitter account, which you can tweet corrections or funny jokes at me, or anything that you desire. But anyways, okay, so that is my presentation. I will now turn my eyes to any questions that may have popped up. Boop, 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 boop. And let me go all the way to the top here. Let's see. Okay, here we are. Okay. It's just a flash moon. Yes, the Black Knight. Monty Python CSI. Totally agree. We should totally make that happen. Is it going to relate to Python? I hope it related to Python toward the end. Digital humanities and social sciences show up over and over in graph database use cases. Yes, true. Let's see. I'm going to now scan for question marks. Okay, here we are. Are Neo4j Cypher and OpenCypher different? Yes, and someone can jump in if they know better, but I believe they are, but very subtly. They're not, I think generally we try to match the OpenCypher spec as best as possible. Should have called it GDQL. Yes. The whole naming drama with graph databases and query languages is, there's many ways it could have gone. GraphQL can be used to DDoS your backend by accident. Oh, that's good to know. I guess you could find some way to DDoS everything. One example of dataform. Dataform. Not familiar with dataform. So I will have to get back to you on that. Python is 20 times slower than Java. Yeah, Python isn't known for being a fast language. It's generally, it's known for being an easy to use language. Although, with version 11 that came out, it's what, 40% faster without you needing to do anything. So, they're working on it. Oh, thank you for the links, Jeff. Okay. I think I've got all the questions. Oh, how close will GQL be deciphered? That is a great question. I wish I was a fly on the wall or had like a security cam on some of their talks. I have no idea which direction they're going at the moment, or what they've thrown out, what they've kept. So if anybody knows anybody on that group or knows where they might be listing that, because I think on the GQL site, so there's a website that the GQL group is maintaining. I don't believe there's like a meeting minutes. At least I didn't find one. So I unfortunately don't know the answer to that, Roy. Okay. All right. If there are no other questions, mostly based on Cypher. That's awesome. That's great. Okay. If you have any other questions, you can put it in chat and I'll answer it later. Otherwise, thank you all very much.